Hello students, let us solve some examples from practice set 5.2 of topic quadrilateral from standard 9th maths part 2. The first question is, in the figure quadrilateral ABCD is a parallelogram. Points P and Q are midpoints of side AB and DC respectively. Then prove that APCQ is a parallelogram. So in this diagram, ABCD is given to be a parallelogram. Point P is a midpoint of AB and point Q is a midpoint of CD. And from this we have to prove that quadrilateral APCQ is a parallelogram. Now to prove this, we have a diagram. It is given that quadrilateral ABCD is a parallelogram, and as it is a parallelogram, its opposite sides must be parallel and opposite sides must be congruent. So by that we can write AB is parallel to CD and AB is equal to CD. Now here it is given that points P and Q are midpoints of segment AB and DC respectively. So if P is a midpoint of AB, we can write AP is equal to half of AB. Similarly, Q is a midpoint of segment CD. That's why CQ is also half of segment CD. We will call this as equation number 3. Now from equation 2 and 3, we have AB is equal to CD in equation number 2, and in equation 3 we have AP is equal to 1 half AB and CQ is equal to 1 half CD. So the right hand sides of equation number 3 are equal as we have proved in equation number 2. That's why the left hand sides of these two are equal, that is AP is equal to CQ. So in quadrilateral APCQ, AP is equal to CQ and AP is parallel to CQ because AB is parallel to CD. That's why AP is part of segment AB and CQ is a part of segment CD. That's why AP is also parallel to CQ. So in quadrilateral APCQ, the opposite sides are parallel to each other and opposite sides are congruent. That's why a quadrilateral is a parallelogram if a pair of its opposite sides is parallel and congruent. So for quadrilateral APCQ, opposite sides are parallel and opposite sides are congruent to each other. That's why quadrilateral APCQ is a parallelogram. Let us consider the next question. Using opposite angles test for parallelogram, prove that every rectangle is a parallelogram. So here we need a diagram. So quadrilateral ABCD is given to be a rectangle and we have to prove that every rectangle is a parallelogram. So now we have to use the properties of opposite angles of a quadrilateral. So we'll start with quadrilateral ABCD is given to be a rectangle. That's why the measure of each of its angle will be 90 degree. That is measure angle A, measure angle B, measure angle C and measure angle D is equal to 90 degree. Now here we have each angle of this rectangle is 90 degree. That's why angle A is equal to angle C, that is equal to 90 degree, and angle B is equal to angle D is equal to 90 degree. So here as we can see, angle A and angle C are opposite angles of rectangle, and angle B and angle D, it is another pair of opposite angles of rectangle. And we have a property, if both the pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. In this case, for rectangle ABCD, the pair of opposite angles are congruent. That's why quadrilateral ABCD is a parallelogram. So as quadrilateral ABCD is a rectangle, each rectangle is a parallelogram. And to prove this, we have used the property of parallelogram, that if both the pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. Let's solve the next question. Prove that a quadrilateral formed by intersection of angle bisectors of all angles of a parallelogram is a rectangle. So diagram is given. In diagram, quadrilateral ABCD is a parallelogram and AS and CR are the angle bisectors of angle A and C respectively. Similarly, ray DP and ray BR are angle bisectors of angles D and B respectively. And we have to prove that the quadrilateral so formed, that is PQRS, is a rectangle. Now to prove this, we start with the given, that is quadrilateral ABCD is a parallelogram, and as it is a parallelogram, we have the property of parallelogram that its opposite angles are congruent, that is angle A is equal to angle C. Now it is given that ray AR and ray CP are angle bisectors of angle A and angle C, as we can see in the diagram. So that's why the ray AR and ray CP are parallel to each other. Similarly, we can prove line DP and line BR are also parallel to each other. That's why a quadrilateral form PQRS is a parallelogram, as its opposite sides are parallel to each other. Now, if it is a parallelogram, then we have angle BAS. In diagram, we can see angle BAS is equal to angle SAD, which is equal to half of angle BAD, because ray AR is angle bisector. That's why these two angles are equal and they are half of angle BAD. Let the measure be x, that is angle BAS is equal to angle SAD, that is equal to x degree. Similarly, we have angle ADS is equal to angle SDC, which is equal to half of angle ADC. So let the measure be y degree, that is angle ADS is equal to angle SDC is equal to y degree. Now we have angle BAD plus angle ADC, that is equal to 180 degree, because angle BAD and angle ADC, these two angles are interior angles of a parallelogram, so they must be supplementary. Now for angle BAD, we have the substitution. BAD, it is the measure of this angle is 2x and measure of angle ADC is 2y. So we have 2x plus 2y is equal to 180 degree. If we take 2 common outside the bracket, we will have 2 into bracket x plus y is equal to 180 degree. That is x plus y is equal to 90 degree. Now consider triangle ASD. For triangle ASD, if we add measures of all the angles of this triangle, that is angle SAD plus angle ADS plus angle ASD is equal to 180 degree, because sum of measures of all angles of a triangle is 180 degree. For triangle ASD, measure of angle SAD plus angle ADS plus angle ASD is equal to 180. Now for angle SAD and angle ADS, we have the substitution x and y plus angle ASD is equal to 180 degree. But x plus y, we have proved it to be 90 degree. So we'll replace x plus y by 90 plus angle ASD is equal to 180 degree. So if we transfer 90 to the right hand side, we will get angle ASD is equal to 180 minus 90, that is 90 degree. So in diagram, as we can see, angle ASD is 90 degree. So its opposite angle will be also 90 degree. That is angle PSR is equal to 90, because they are vertically opposite angles. So angle PSR is of 90 degree. Now we have one property that if one angle of a parallelogram is a right angle, then it is a rectangle. So as quadrilateral PQRS is a parallelogram, which we have already proved. For this parallelogram, we have now just proved that angle PSR is 90 degree. So all the remaining angles of this quadrilateral are of measure 90 degree. And that's why quadrilateral PQRS is a rectangle. That is, we have to prove.